All right, we are going to get started with the 3-2 notes. And this video is going to be about the substitution method. So if you remember in class, we talked about how there are 3 different methods for solving systems. The first one is graphing. So for example, if I had y equals x plus 2 and x plus y equals 8, and I asked you to solve that system by graphing, we could do that, right? This one's already in slope-intercept form. Y equals x plus 2, that's in slope-intercept form. This one, I would have to get y alone first. So I'd subtract x from both sides, and that would give me y equals negative x plus 8. Then I can graph them. So x plus 2, up 1 over 1. See if I can get it to line up here, what I want. Okay, there's my x plus 2, negative x plus 8. There we go. And then we find the point where they intersect, and that is 3, 5. So my answer is 3, 5, right? This is the graphing method. We've done this one already, okay? What I'm going to do in this video is I'm going to show you how we can solve this system without having to make a graph, which I think will make a lot of you very happy because from what I've heard, graphing is time-consuming and you don't like making a bunch of graphs. So let's see if we can solve this exact same system, which we already know our answer should be 3, 5, by using the substitution method. So here we go. Example 1, same system. Now here's the key with using substitution. You need to find a variable that is alone. Find a variable that is alone. Now, what do I mean by that? Well, x and y here are not alone because they're both on the same side of the equal sign. The only variable that is alone is this y in the first equation because it's the only thing on that side of the equal sign. Now, what does y equal? Y is equal to x plus 2, and I want you to circle that x plus 2. Now, I want you to think about if you play soccer or volleyball or football or basketball. I want you to think about you make substitutions in the middle of a game, right? One person comes out and another person goes in their place. Or think about if I'm ever gone for a day. I leave and a substitute comes in my place. That is exactly what substitution is in this context as well. So I want you to look at this second equation. We have x plus y equals 8. Well, instead of writing a y here, I have something else that can go in its place. Now look at the first equation. We know that y is equal to x plus 2. So instead of writing a y here, I can write an x plus 2. So this is what it's going to look like now. I'm going to have x plus, instead of y, we're going to have x plus 2. Now this is an equation I can solve. X plus x is 2x. Subtract 2 from both sides. Divide by 2. Oh, shoot, I was going to do that in purple. And we get x equals 3. Now, we're not done because we need to know what y is. We only know what x is in this case. So I'm going to go back to one of my original equations. It doesn't matter which one. I'm going to choose this one, this top one. I know that y is equal to x plus 2. But now I know that x is equal to 3. So guess what? Y equals 5. And we get 3 comma 5, just like we did when we did it with the graphing method. All right. So that was part A. B. All right, here's what I want you to do. I want you to find the variable that is alone. Did you find it? It's this one, the y equals. And what does the y equal? It equals 2x minus 1. I want you to circle it. Now, this 2x minus 1, if I look at this second equation now, this 2x minus 1 can go in the place of the y in the second equation. Now, this is very important. I want you to watch very carefully how I make this substitution. So, I still have 3x plus 2, but instead of y, we put 2x minus 1. And I want you to notice that I put parentheses. The parentheses are very important. So now I can solve for x. I'm going to distribute. I still have 3x plus 4x minus 2. Combine like terms. Now I'm going to add 2 to both sides. Gives me 7x equals 28. Divide by 7. We get x equals 4. Okay, what do we do now? We take that answer and we go and plug it in up here. I know that y equals 2x minus 1, but now I know that x equals 4. So what do I get? If x is 4, I get y equals 7. So my answer is 4, 7. All right. Part C. I'd like you to write this down. Y equals 3x plus 5 and x plus 3y equals negative 5. I would like you to pause the video and try this one on your own. All right, you should have gotten -2, -1. If you did not, make sure you carefully look back through my work to see what you did incorrectly and see if you can fix your mistake. All right, let's try another example. But this time, we're going to have a little bit of an issue. So what's the issue? Well, the issue is that if you look at both of these equations, there are no variables that are alone, okay? They have something else with them on that side of the equal sign. Now, what you're going to have to do is rearrange the equation so that one of the equations has a variable that is alone. Now, both of these equations, you could very easily get y alone, and it doesn't actually matter which one you get by itself. Just pick the one that makes the most sense to you. And for me, it makes the most sense to me to look at this second equation and say, well, I'm going to add 8x to both sides, and now I have y equals 8x plus 1. And now I have an equation that has a variable by itself. So now I can take this 8x minus 1, and I'm going to plug it in to the y in the first equation. So that's going to give me 2x plus 8x plus 1 equals 6. That gives me 10x plus 1 equals 6. I'm going to subtract 1 from both sides. So that gives me 10x equals 5. I'm going to divide by 10. And 5 divided by 10 is 1/2. So x equals 1/2. All right, I'm still not done. I have to figure out what y is. So I'm going to use the fact that y equals 8x plus 1. And now I'm going to take this 1/2 and I'm going to change x to be 1/2. So y equals 8 times 1/2 plus 1. What's 8 times 1/2? Well, 8 halves is 4. So y equals 5. So my answer is 1/2, 5. All right, let's take a look at this one. Oh, whoops. Gotta do 2 lines. All right, you might look at this system and say, oh, great, y is by itself. And I say, well, hey, what about that negative? That's not going to fly, okay? If you have a negative y and you need a positive y, all you have to do is flip the sign of everything. So watch this. If I want this to be positive, I'm going to change the sign of everything. So my positive 2x is going to become negative 2x. My minus 2 is going to become plus 2. Equals, now my negative y becomes y. And now I have the y all by itself. Take that negative 2x plus 2, substitute it in for the y in the first equation. I would like you to pause the video and try to finish solving this system on your own. All right, sorry my work is a little cramped on the bottom of the page, but you should have gotten x equals 3 and y equals -4. All right, that is going to be it for the substitution video. We have one more method to cover, and that is called elimination. And we will talk about elimination when you are in class next time.